Bismillahirrahmanirrahim. Today I'd like to talk about simplifying radical expressions. Our goal today is to learn how to simplify expressions like this. Let's say 8x to the 5th, y to the 4th, and z to the 7th. How do you go about simplifying expressions like this? The first thing we have to do is understand what it means to take a square root. So if I give you square root of 25, for example, that's easy enough. You'd say the square root of 25 is 5. Similarly, if I had told you what's the square root of 16, you would have said, oh, that's easy. The square root of 16 is 4, because both 25 and 16 are perfect squares. But what about square root of 20? Now, 20 is not a perfect square. And if you take a square root of 20, you get an irrational number. See, here it is. So if you take a square root of 20, you get something like 4.72135955, and it goes on forever. But you know that approximately what this means. That is, if you take 4.4721 and multiply by itself, you would get 20. So you understand that square root of 20 is approximately 4.47. But what does this mean? Now, this means that if you take 4.47 approximately and multiply it by 4.47, you would get about 20, correct? And if you were to do an exact irrational number, you will get 20. Just like that, 4 multiplied by itself will give you 16, and 5 multiplied by itself will give you 25. So now I hope you understand what it means to take a square root of 25. When we take a square root of 25, what we're really saying is what number multiplied by itself will give you 25, and that of course is 5. Now when we write the square root of 25, what we typically omit is the 2 that's over here. See, there's an invisible 2 over here. You don't see it because it's invisible, but it's there. We typically don't write it because it's the most common root that we take. The square root, therefore, is not the only root that we can take of a number. For example, you can take a cube root of 25, you can take a 4th root of 25, and you can take a 5th root of 25. Now, what does it even mean to take a cube root of something? What does it even mean to take a 4th root of something? And what does it even mean to take a 5th root of something? Well, the concept is the same. See, when you take a cube root of something, what you're saying is, instead of saying what number multiplied by itself twice, what you're saying here is what number multiplied by itself 3 times will give you 25. And when you take a 4th root of something, what you're trying to say is what number multiplied by itself 4 times will give you 25. And when you take a 5th root of 25, what you're saying is what number multiplied by itself 5 times will give you 25. Now these, mind you, are identical numbers. Whatever goes here, and goes here. Now look, the cube root of 25 is 2.924. In other words, 2.924 times 2.924 times 2.924 will give you 25. The 4th root of 25 is 2.236 ... It's an irrational number. If you multiply 2.236 by itself 4 times, you get 25. In the same way, the 5th root of 25 is 1.904 approximately, because this 2 is an irrational number. So the second thing that we must understand is that we can take square root of 25 and we can take any root of 25. Typically when we take a square root of 25, because that's the most common root that we take, we don't typically write the 2 over here. But it is understood. When you don't write it, we're taking a square root. When we take a square root, we're asking ourselves, what number multiplied by itself will give you 25? The square root of 25 is 5. There is some terminology associated with square roots. Now this here is a square root because we didn't write anything there. But if you wrote something over there, you won't call it the square root anymore. You just call it simply the radical sign or the radical symbol. The root that you take over here, that's called the index. This number over here, let's call it a 3. Now this 3 is called an index, or sometimes the degree. And whatever you're taking the root of, that's called the radicand. So this is a radical symbol, radical sign. This is the index, whatever root you're taking, or the degree, and whatever the root you're taking of, that's called the radicand over here. And the whole thing is the radical expression. Now, if you understand that square root of 25 is 5 times 5 like this, what number multiplied by itself gives 25, and that's 5. From this, you have to understand that square root of anything multiplied by itself like this is that thing. And if I have square root of 4 times 4 is 4. The square root of 16 times 16 is just 16. In the same way, square root of x times x is going to be x. Square root of y times y is just going to be y. From this, we understand that square root of x squared is x, and the square root of y squared is going to be equal to y. In order to simplify radical expressions, we need to understand this. That is, square root of x squared is x. The reason for this is this. And the reason for this is this over here, conceptually. So, in order to simplify radical expressions, you have to know the following. You have to know simple things like square root of 25 is 5. The reason is because it's 5 times 5. That is, 25 can be written as 5 times 5 like this. And from here, we understand that square root of x squared is x. From this, you can say in general that for every pair that you have for a square root, it will be simplified as 1x. And if it was a cube root of x cubed, that is 3x's, that would be x. And a cube root of y cubed would be y. In the same way, if you take a fourth root of x to the fourth, it will be x, because the fourth root of 5 times 5 times 5 times 5 is 5. There's one rule that we have to appreciate. This is one property or rule regarding radicals that we need to understand. And that is simply like this. The square root of a times b equals the square root of a times the square root of b. If you have a product under the roof or the umbrella of a radical symbol like this, you can separate them into two radicals like this. So the square root of a times b equals square root of a times the square root of b like this. And this goes both ways. It goes like this, and it also goes like this. If you have a product of square roots, you can bring them together as one like this. Now, armed with these concepts, we are ready to simplify radical expressions. How about this one? Square root of 25 times x squared. Now this is a square root because we didn't write the invisible 2. When we don't write anything in the index over here, it is assumed to be 2. So square root of 25 times x squared, now you can divide this into 2 like this. So you can take square root of 25 times the square root of x squared. Or you can just work with it, so to speak, like this, okay? So what's the square root of 25? Well, that's a perfect square, right? Square root of 25 is 5. Correct? And then what about x squared? Well, we're taking a square root for a root of x squared. If we're taking the square root like this, is simply x. So this is going to be x like this. Okay, that was too easy to say. Okay, how about this one? We have square root of 50 times x cubed. Again, we're taking a square root. Here, we have to do prime factorization. We have to find the prime factors of 50. That's 2 times 25. And 25 is a perfect square. And if you didn't know that, then you would write that. So, okay, so good. Now we can rewrite this as this. So you have square root of 2 times 5 times 5. And then we have x cubed. So the general rule is whatever is under the roof or the umbrella of the square root sign or the radical sign, if it's a square root, 2 of them will come out as 1 over here because square root of 5 times 5 is just 5. The general principle is that whatever is under the roof of the radical symbol or the radical sign, if you're taking the square root, every pair will come out as 1 from here. So this is 2 times 5 times 5. The 5 will come out. But the 2 won't because it does not have a pair to come out with. It does not have a best buddy to come out with. So the 2 will remain inside. Similarly, you have x cubed. X cubed can be rewritten as x to the first times the x to the squared. Now this x squared can come out from the umbrella of the radical sign because x squared is x. So this will come out. So this square root will come out like this, and that will become x. But this other x will remain inside, like this. So square root of 50x cubed, you can simplify this by first breaking down the 50 into its constituents 2 times 5 times 5 by prime factorization. Once we do that, we understand that these two 5s can come out, so to speak. They can exit the radical symbol, and then the 2 will remain inside. And this x is x to the first times x squared, and these two will come out as a pair as 1. This 1x will remain inside. What I like to suggest to people is, for every 2 x's over here, they'll come out as 1. Like if you had a slice of bread with peanut butter and another slice of bread with jelly, they come out as 1 peanut butter jelly and not 2 slices of bread. So for every 2 slices, you get 1 sandwich. That's for square roots. For square roots, for every 2 slices, they'll come out as 1. For cube roots, for every 3 slices, they'll come out as 1. For fourth roots, every 4 slices, or 4 of whatever it is inside, 4 of them would come out as 1. So let's do some more examples. How about this one? Well, we're taking a square root still, so we have to do prime factorization of the 8. So 8 can be rewritten as 2 times 2 times 2. And then you have x to the 5th y squared. A quick review. This is called a radical symbol. This is called a radicand. This is the index, which is not written over here. Since this is a square root, for every 2 will come out as 1. 2 slices of bread will come out as 1. So the one of those 2 will come out like this. Now, I like to write this radical symbol so I don't miss out any numbers. So this 2 is remaining inside, so that stays right there. Now we have x to the 5th. Now that can be rewritten as x to the 1st times x to the 4th. See, whenever you're taking a square root or even numbers, right, you'll have 1 left over. So x to the 5th can be written as x to the 1st and x to the 4th. So here you have 4 slices. Well, how many sandwiches can you make out of 4 slices? Well, 2, of course, so that's x to the 2. And this 1x will remain inside. Then you have this y squared. Well, you have 2 slices of y, so to speak. You can make 1 sandwich out of this. Y squared will come out as y. And there'll be no y's left inside, see? This will be 2x squared y times the square root of 2x. So this expression will simplify to this. Square root of 40, e to the 5th, e to the 7th, and r. Well, we have to do the same thing. So prime factorization of 40 is this over here. Okay, so I can rewrite that. You don't really have to rewrite it. After a while, you get better at it, see? But now we're going to just rewrite it. So that's 2 times 2 times 2 times 5, okay? For every 2, 1 will come out. Now, these 2 are stuck in there. So that's 2, and then I'm going to put that in there and multiply them out as 10. There are 5 p's, right? There are 5 of them. So the 5 p's, that's p to the 1st times p to the 4th, right? So this 1p will stay inside, and these 4p's will come out as 2 because you're going to be able to make 2 sandwiches out of them 4p's, right? And then q to the 7th. Now q to the 7th is q to the 1st times q to the 6th, right? So you can make 3 sandwiches there, and 1q will remain. And this r, well, tough luck for r because it's only got 1 there. So the r will remain inside. So this expression will simplify to 2p squared q to the 3rd times the square root of 10pqr. Got it? Now we're taking cube root of the following. 8 x to the 5th, y to the 6th, and z. The approach is the same. We have to do prime factorization of this 8. So that's 2 times 4, and that's 2 times 2. The prime factorization of 8 is 2 times 2 times 2. Okay, so we can rewrite this. Now we have to make sure that we write that index in there as 3. We're taking a cube root here. We're not taking a square root anymore, okay? So that's 2 times 2 times 2. And then we have the rest of the radicand. All right, now, see, 3 of these will come out as 1. Because this is a cube root, it's like a 3-slice sandwich. It's a bigger sandwich. So those 2's will come out outside like this too. And there'll be nothing left inside because we're taking a cube root. All 3 of them come out. It's like a 3-slice sandwich, a big sandwich. Yummy. Now we have x to the 5th. See, x to the 5th is x squared times x cubed. Now this x cubed will come out as 1x. And this x squared, however, will remain in size. And then y to the 6th, well, how many sandwiches can you make out of the 6 over here? Well, it's going to be a 3-slice sandwich, right? So this is going to be y squared on the outside. All of them will come out. That's a multiple of 3. And z, tough luck, bro. You're sticking in there. This, therefore, will simplify to 2 times x times y squared, cube root of x squared, and z. Okay, let's do one more example. Let's take another cube root. So I have cube root of 27 m squared n to the 7th and k. So the prime factorization of 27 is 3 times 3 times 3. And I better write this 3 over here to remind that I'm taking a cube root and not a square root. And simplifying this 3, I'll just rewrite this 3 from here. Now these 3 over here, they will come out because this is a 3 slices and you'll make 1 sandwich because we're taking a cube root. And then I'm going to write the radical symbol over here. But then I have m squared n to the 7th and k. I better write that cube root over there again. Okay, so you can simplify these over here. So that 3 times 3 is 9. Okay, and we have a cube root of m squared n to the 7th and k. It's going to be 9 times. Well, what are we going to do with the m's? Nothing, because you only got 2 of them. You're going to have 3 slices to make sandwiches here. You're not going to be able to do it, okay? So the m is going to stay inside m squared like this. Okay, what about the n? We got 7 of them. Okay, that's pretty good. That's n to the 1st times n to the 6th, right? So these 6 will come out, right? Because you can make 2 sandwiches out of them, and 2. So 6 will come out. 1 of them will remain because we're taking cube roots. How about this k? Nothing. The k will have to remain inside. So this whole thing, the expression simplifies to 9n squared times the cube root of m squared n times k. And that, I believe, is the answer. So in summary, what we have learned here are important things. And I first suggested that you can take a square root of 25, but then you can also take a cube root of 25, and you can also take a 4th root of 25. I've also suggested to you that this is called the index, and sometimes that's called the degree. The whole thing is called the radical, and this here, whatever's inside, that's called the radicand. The second thing I suggested to you today, the important rule, is the square root, or any root, of a times b equals the square root of a times the square root of b, and this rule goes both ways. And I suggested that if you're taking a cube root of something, you have to have 3 of those things for them to come out like this. And if you're taking a 4th root of something, you have to have 4 of those things inside as a radicand to come out as 1. 3 slices will make 1 sandwich with a cube root. 4 slices will make 1 sandwich in the 4th root. And 5 slices will make 1 sandwich in the 5th root. Inshallah, we shall elaborate on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.